Hey, welcome to our first e-learn. So right now we're going through Form 4 Chapter 5. Okay, so this is the first part out of two parts. Okay, so this is the notes part where I'll teach. Later we will have one question during session. Alright, so uh, straight away into the notes. So page 2, Metabolism and Enzymes. So this chapter, remember, is actually very closely related to your chapter 4. Okay, how later you will see lah. Okay, so enzyme is actually something that helps out with our metabolism. So what is metabolism? So you probably always heard about body metabolism, metabolic rate. So what's that actually? So they say here it's all biochemical reactions that occur in living organisms. For example, the reactions that we learned in chapter 4. Okay, like remember how lipids, okay, fats, if react with water, it will be broken down into glycerol and also fatty acid. So if you remember, this process is actually called hydrolysis, because you water to break down something. Okay, so this is actually a digestion process as well, whereby when you eat lipids, your body will digest it into glycerol and fatty acids. So digestion actually is a biochemical reaction. Okay, so remember in chapter 4 you learned that also this process can be reversed. So that's also a condensation process if I reverse the process. Okay, yeah, so that is actually biochemical reaction. So here there are two types of metabolism. So anabolism and catabolism. One of the example of anabolism is that we just mentioned, it's condensation. Okay, where I use smaller molecules to form a larger molecule. Catabolism, example of it is hydrolysis, whereby I take a large molecule to break it down into smaller units. Okay, so it's already explained here. It is the process of synthesizing complex molecule, and catabolism is the process of breaking down complex molecules. Okay, so one is like formed by condensation, one is breakdown just like hydrolysis. Okay, so how to remember this? So you just remember like C catabolism stands for cut. So I cut something, so it's breaking down. Okay, now what's the example of anabolism and catabolism in living things? So for example, photosynthesis. So photosynthesis is actually a type of anabolism. So if you remember back your form 2, form 3, photosynthesis, what do you need for the process? Number 1, you need water and also carbon dioxide, right? And then obviously you also need sunlight. So sunlight is basically light energy. So when all these things combine during photosynthesis, you will produce, as you learned before, glucose, the main product, and a byproduct, oxygen. Okay, so if you compare to here, okay, you can see that it's actually anabolism, whereby I use smaller units, which are water and carbon dioxide, combined with energy, which is light energy, to form a larger molecule, which is glucose, is the large molecule. Okay, now if you were to reverse this process, what's actually that process? So oxygen plus glucose become water, carbon dioxide, and energy. So that's actually what we learned before as respiration, also known as cellular respiration. Okay, so why you need to breathe oxygen? Why you need to eat food? So that your cells can combine these two, oxygen, glucose, to give your body energy. So it's already written here, glucose is broken down to produce energy during cellular respiration. Okay, see the diagram here? I break down the larger molecule, which is glucose, into smaller molecules, which is water and carbon dioxide, and also energy. Okay, So that's it for metabolism. Okay, so next we'll look at enzymes. Okay, just this. Okay, so what are enzymes? So enzymes, you probably also learned it before during your digestion punya chapter in form 2. Okay, whereby enzymes is used for digestion, helps in your digestion. So it explains here, it is a biological catalyst which speeds up biochemical reaction. So again, biochemical reaction is like digestion, you speed up your digestion punya process. So what is the meaning of catalyst? So catalyst is something that speeds up a process. Okay, biological catalyst means it's a natural substance. So for example, let's say if I have hot Milo, if it's too hot to drink, I will put it down on the table to let it cool down. But this process is slow, isn't it? So to speed up the cooling process, you will do what? You will put ice. So ice will speed up the cooling process. So in this cooling process, ice is my catalyst because ice speed up my cooling process. So enzymes is the catalyst of biochemical reaction. So enzyme speeds up your biochemical reaction. So just like just now this process here. Okay. Alright. To digest lipids, right? When you eat food, not just lipids, but just like any other food, the digestion process could take very long. Let's say maybe up to a day or two. But takkan you going to keep your food in your body for so many days, ma? How does your body store so many food? Correct? Today you eat, the next morning you go to shit it out. So to speed up this process, your body needs enzymes. Where we learned before, the enzyme that digests lipid is called lipase. So lipase will speed up the digestion process so lipids can be quickly broken down into glycerol and fatty acid. So instead of 1 or 2 days, within few hours the digestion is complete. Next morning you can go to the bathroom and let it out. Okay? Yep. So here are all the examples of enzymes that you will learn or come across. These enzyme names you don't really have to memorize it that seriously in this chapter because during digestion the chapter 10 only will be going through each one by one detailly. So now you just agak-agak remember, especially the disaccharides. Remember in chapter 4 we learned about the disaccharides. So each of the disaccharides, to digest them, the enzymes just change the O to A. So sucrose punya enzyme is sucrase, maltose is maltase, lactose is lactase. So cellulose is digested by cellulase, and as we mentioned, lipid is digested by lipase. Okay. Now, right hand side, this one are the proteins. So if you remember your digestion punya chapter last time, and also in chapter 4 we just got mentioned, protein is being digested 3 times. It is broken down 3 times. First time becomes polypeptide, second time it becomes dipeptide, and the third time it becomes amino acid. So last time you learned that the enzyme that digests protein is called protease, and protease. But right now protease broken down 3 types. So pepsin is the one that breaks down protein to polypeptide, trypsin, polypeptide to dipeptide, erepsin, dipeptide to amino acid. Okay, yeah, so protein, the enzymes all like sin one. Okay, now, so here this is substrate. Okay, so what is substrate? Okay, so forgot to mention, substrate, okay, lipase is your enzyme. The food that's digested by the enzyme, such as lipid here, is called your substrate. Okay, the substrate that's being broken down into these 2 fatty acid glycerol is called your products. Okay, so basically enzyme breaks down substrates into products. Okay, so the first part of enzyme, the first topic of enzyme is the characteristics. Okay, now there are 6 of them. The first 2 are quite simple, very straightforward. Number 1, enzymes are all proteins. Remember, just like we learned in chapter 4 and chapter 2, enzymes are made of protein. So that's one of the most basic characteristics. Okay, now next, enzymes are biological catalysts, as we just mentioned. They speed up. Okay. And next, enzymes are, okay, 3 and 4, these 2 are the most important one. Okay, enzymes are not destroyed at the end of enzymatic reaction, hence they can be reused and only needed in small quantity. Okay, so what does that mean? For example, lipase, we come back here. Okay, so when lipase breaks down the lipids into glycerol and fatty acid, the enzyme is, the lipase will still be there. Means only the substrate is broken down. Substrate, enzyme still there. So which means the enzyme can be reused. So you can still break down other lipids that comes into your body. That's why if it can be reused, I only need it in small quantity. Okay, so that's why it's small quantity, just like my bottle. Okay, why I only need 1 bottle? Why I only need in small quantity? Because if today I use already, at the end of the day, it doesn't break down, it doesn't spoil. So tomorrow, I still can refill water, reuse it. To next week, next month, also can reuse. That's why I only need 1 bottle, small quantity. Okay, understand, right? Okay, so next, enzymes are highly specific. Active sites of enzyme can only bind to specific substrates. So, what does that mean? What is active site and all? Okay, so, okay, look here. I'll show you real quick. So let's say this is an enzyme called sucrase, the one that digests sucrose. Okay, so just now we mentioned, we look at your notes. Each enzyme can only break down 1 type of substrate. Like sucrase can only break down sucrose. Maltase can only break down maltose. Okay, so like for example, sucrase can only break down like maltose or even lipid or even lactose. So what is because sucrase right now, not just sucrase, but okay, let me just okay, so not just sucrase, but all enzymes, they will have a part that have a shape one. So this shape here is called the active site. So different between enzyme, right? The active site between shape is different. Okay, so why sucrase can only go and break down sucrose? Because sucrose punya shape, is ngam can fit into the active site of sucrase. That's why therefore sucrose and sucrase only can have reaction. Maltose cannot be broken down by sucrase. Lipids also cannot be broken down by sucrase because maybe their shape, because their shape are completely different. So let's say maltose punya shape is like this. Let's say lactose punya shape is like this. So if the shape doesn't fit into the active site, reaction cannot occur. So sucrase cannot break down other substrates other than sucrose. Okay, understand? So therefore, they say here, highly specific means that one enzyme can only specifically break down 1 type of substrate. Because the active site of enzyme can only bind to specific substrate. So for example, sucrase is the specific substrate for sucrose. You only can bind to sucrose when you're active site. Alright? Can I? So Next two, actually nothing much. Enzyme activity can be slowed down or stopped by enzyme inhibitors. Inhibitors is like a type of chemical type poison that slows or stops the reaction. We will do that in the questions later. Most of the reactions catalyzed by enzymes are reversible. So which means enzyme doesn't just break down something, it also can form something. So lipase doesn't just break down lipids into glycerol fatty acid, it also can form them back together. But in our syllabus, right, we only will learn enzyme breakdown thing lah. We won't learn enzyme form thing. Okay. Yep. So that is the first part. Okay. So the second and last part for this video is enzyme punya reaction. So enzyme reaction, what does that mean? Means like for example, how does lipase break down lipid into a product? So how does enzyme break down substrate into the product? So you have to explain that reaction. Okay, see you have enzyme, for example, this is like your lipase, your substrate is lipid, and then the products, glycerol, fatty acid lah. Okay, now, so they also say here that enzyme reaction is the lock and key hypothesis. So why lock? Why lock? And then why key? So here, if you look at substrate and lock, right? Substrate and an enzyme, right? It's actually just like a lock and a key, whereby your substrate acts as the key, enzyme act as the lock. Because in real life, key is used to chuchuk into a lock and open it. So here you can see substrate, chuchuk, enzyme. Okay, so lock and key is actually very specific, just like the enzyme substrate. What does that mean? It means that if I have a key that opens my door, the same key cannot get open your house punya door, because this key doesn't match the shape with your house punya door, but only match my door. Therefore, it can only open my door. Just like how sucrose can only bind with sucrase, how does maltose can only bind with maltase? It's the same thing. Because of the shape of the active site, it is highly specific. Okay, can. So here is just like looking at a diagram and tell story. It's like exactly your explanation is exactly from the diagram. Very simple one. Okay, so this will normally ask around 6 to 7 marks punya essay. Okay, so if let's say the question is like 6 to 7 marks, right? Okay, before you start explaining, right, you can first say that enzyme is the lock, substrate is the key. Okay, then we start by saying the specific substrate binds to the active site of the enzyme. So remember, you must say specific substrate binds to active site of the enzyme. Okay, a lot of you will say substrate bind to active site. Sorry, substrate bind to enzyme. No, you must say bind to active site, because you cannot bind to the head, bind to the butt. There's only one part of the enzyme substrate can bind, which is active site. So very important, must say specific substrate bind to active site. Okay, so when the enzyme and substrate join together, what do they form? They form an enzyme substrate complex. So when an enzyme and substrate join together, we call this an enzyme substrate complex. So this complex, they say here, is not stable. It means the reaction is not stable. It means it can be broken down very easily, very fast, not stable. Just like if I have a boy and girl, a couple. So if the couple is not stable, means they always argue. Means in the end, they're very easy to break up. So if you look here, okay, almost exactly the same thing, whereby you will see that the enzyme breaks down the substrate into the products. So at the end of enzyme reaction, products are formed. So just like the lipid become glycerol, fatty acid. Okay, so just imagine like this. Now the couple break up already. So when couple break up, girl usually very easy to heartbroken. So the products here are like the girls like that. Okay, so when boy they break up, they always like whatever lah, not me okay, just the most okay. So when they break up already, they are like, never mind lah, whatever. So they are still in one piece. So when the girl break up already, she very sad, she heartbroken. What happened to her? She leave the boyfriend, okay. Then the guy, if nothing happened, what will he do? He will find another girl lor. So he already got out, no more girlfriend mah, so find another girl. Okay, why am I telling you this? Because this is what is the exact thing you need to explain over here. Okay, point actually 6 and 7, sorry, the numbers jumbled up. A lot of you, right, will stop your explanation at this point, whereby when you all say enzyme is broken down, it breaks down the substrate into the products, then you'll end there, stop there. But let's say the essay is 6 to 7 marks. If you write like that, right, you won't get the full marks. So you must further explain the last two steps, whereby just like I say, girl heartbroken, leave the boy ma. So here, the products leave the active site. So the boy, what happened? Boy, nothing happened ma. So boy does not break down, enzyme does not break down. And then what happened? He got out, find another girl lor. So free to find two other substrates. Understand? Okay? Yep. So that is the log and key hypothesis. So I will end this video right here. The next part of the enzyme will continue in the next video lor. Okay? Bye bye.